Welcome to 9.7, everybody. It's plane curves and parametric equations. So this is kind of the cool section because we've just been like living in this world where everything was done in like the Euclidean geometry world, where it's based off this rectangular region. And you're gonna see in the higher math that you get that alternating the way that we approach the equations can make the work a little bit more efficient and can give rise to ways and better ways to view applications to the real world. And so the way that parametric equations work is like, let's just say we had the points 1, 2, 3, 1, 4 here, and it's just, we know that to be at the point 1, 4. But in this world of parametric equations, we introduce another variable, the parameter t, and what it tells us is that at some time t, the x-coordinate is 1, and then the y-coordinate is 4. So like maybe t equaled 0, for instance. And so the start of whatever thing we're talking about is going to be at 1, 4. So what parametric equations do is it gives you that point in the two-dimensional plane of where you're at with respect to time. So for instance, you throw a ball or you go golfing, you're going to know that spot based off that time t. So you're going to know how far it went on the x-axis and how far it went up on the y-axis. Okay, so when we're doing these, I find it really helpful to just make a table. And this time we're going to have 3 columns. It's 3 because, well, in this case, the domain for our t variable is from 0 to 3. So we're going to be plugging in the numbers 0, 1, 2, and 3 into the equation for x and into the equation for y. And so I changed the way this is written as well, is that this is still a function with respect to t. It's just giving you that value. The output is the value on the x-axis, and similarly here, for some value of t, the output is the y-coordinate. And so we often just abbreviate x of t with x and y of t with y. And so what we're going to do is plug in numbers for 0, plug in the numbers for t to find x, plug in the numbers of t to find y. And so when we go through this, it's going to be, so plugging in 0, 6 minus 0 is 6, and then really manipulating our slope because we're increasing by 1 for the t, we'll have the values 4, 2, and 0. So since that slope is -2, I can keep subtracting 2. I'm just going to go from 0 to 3. Now just repeat that for the y of t. So then when you plug in 0, we'll get -2, and now we're going to keep adding 4. So we get to 6 and 12. 4, 10. Alright, and so what we essentially have now is that these are the ordered pairs that we'll plot here. And so I have a 6, -2. So I have a point here. And another one is 4, 2. And we have 2, 6. And 0, 10. Okay, so we just plotted those points. We can tell that if we were to plug in like a half or, 3/4, the the pattern that we're seeing is that it's going to start here and go up. And it stops at that ordered pair 0, 10. And the other key thing with parametric equations and structures will take off points is that you need to put the direction that the curve is going. So as t is increasing, draw the arrow of which way the points were going. So since we started at 6, -2, and then 4, 2, and 2, 6, we had to orient the direction of the curve going in the upward direction. And the other thing we want to do with this problem is find the rectangular equation. There's a couple ways that we can approach this. What you want to do is look at each of your equations and ask yourself, which equation is it easier to isolate t for? And since these are both linear, just for comfort, we might as well just write this as y is a function of x, which means we would want to solve for t in x and plug that into the t for y. So we're gonna say, let's go ahead and add 2t and then subtract x. So 2t is 6 minus x, and then divide both sides by 2. We'll get 3 minus 1/2 x, or x over 2. And then now we're going to plug that in, plug our value for t into the equation for y. So this means we'll have y equals -2 plus 4 times 3 minus x over 2. And just go ahead and clean this up. We'll end up with -2 plus 12 minus 2x, and -2 plus 12 is 10 minus 2x. So the thing is, at this point, you still want to stop and pause, because we're still supposed to only capture the part of the graph that's given. And technically you're plugging in all the real numbers in here and you're getting the whole line. So you want to restrict the domain. So for what values of x will we get that same graph? Well, it might be good to just look at it as, when we look at the x coordinates, the first one is 0. And when you plug in 0 for x, you get 10, so that matches. And then if you count over, right, 1, 2, 3, 4, 5, 6, the next x coordinate that we get that's a point is -2. So if x is 6, 10 minus 12 is -2. So then we can say that the domain is on 0 to, oops, I put 3, 0 to 6. And so the answer would be y equals 10 minus 2x for x between 0 and 6. Alright, we'll see another problem in the next video.